Imagine you've done it. You've
Oh.
you've actually done it.
Built the impossible.
Right. You've built the very first human warp drive.
A massive achievement.
Oh, absolutely. So you load up your crew, you engage the engine, and you travel across the galaxy to a neighboring star system, like in the blink of an eye.
Just zoom in right over there.
Exactly. But here's the kicker. The moment you hit the brakes to say hello to the locals.
Oh, no.
Yeah. You accidentally incinerate their entire solar system. Just vaporize it with an invisible wall of infinite sterilizing radiation.
Not exactly the best first impression for humanity.
Definitely not. And welcome to the blue sheet.
Right.
It's the ultimate mathematical nightmare. It's the thing that has completely stalled faster than light travel for, what, 30 years?
Yeah, about 3 decades now. It's really the ultimate cosmic paradox.
How so?
Well, you finally figure out how to beat the speed of light, right? And the universe's reward for your genius is turning your spaceship into a weapon of unimaginable mass destruction.
Which is just terrifying. And that brings us to our mission for you today on this deep dive.
We have a lot to unpack.
We really do. Because for 3 decades, the brightest theoretical physicists on the planet have been staring at this exact problem.
Staring at a brick wall, essentially.
Right. The math of the warp drive actually works, but the physical result seems to be certain death.
Yeah.
But what if this seemingly insurmountable physics problem, this death wall, isn't actually a physics problem at all?
This is the crazy part.
What if it's just a framing problem?
And that is exactly the core of what we're looking at today. It's a story about what happens when you realize you've been trying to solve this incredibly complex puzzle, but you have half the pieces missing from the box.
You're using the wrong box entirely.
Exactly.
So by the time we are done today, you listening to this, you're going to understand the absolute cutting edge of frontier physics.
And no textbooks required.
I promise you won't need a single textbook. We are going to break down the hardest concepts in the universe using windshields, steam engines, and playground equipment.
The best kind of physics.
Right. But to understand how to fix a broken warp drive, we first have to understand the invisible wall that has been crashing them.
The blue sheet.
Yes. So we need to talk about the concept of blue shift. Walk me through this.
Okay, so blue shift is the foundational mechanism here. And to really grasp it without getting bogged down in equations, it helps to start with something we experience in everyday life.
Like sound.
Yeah, exactly. The Doppler effect for sound. Imagine you were standing on a sidewalk.
Okay, I'm on the sidewalk.
And an ambulance is, say, a mile down the road. It's driving toward you very fast, and it has its siren blaring.
Right. Everyone knows this sound. The siren starts at really high pitched, and then the exact moment it passes you, it drops to a lower pitch.
The classic EU sound.
Yes. Perfect sound effect. But why does it actually do that?
Let's look at the mechanics. Sound travels in waves through the air, right?
Okay.
So as the ambulance speeds toward you, it is physically chasing its own sound waves.
It's catching up to the noise it just made.
Precisely. It pushes them. The waves get bunched up or, squished together in front of the vehicle.
Like an accordion getting squeezed.
And that's a great visual. Because those waves are compressed into a tighter space, they hit your eardrum much more frequently.
Bip, bip, bip.
Right. And in acoustics, a higher frequency, more waves hitting your ear per second means a higher pitch.
Oh, okay. So squished waves sound high.
Exactly. But the second the ambulance passes you and starts driving away, the whole dynamic flips.
And because now it's running away from the sound waves.
Right. It is moving away from the sound waves it's emitting toward you, so those waves get stretched out.
Like pulling a slinky apart.
Exactly like a slinky. A stretched, longer wave hits your eardrum less frequently, so the pitch drops.
Okay, so squish waves sound high, stretch waves sound low. That completely tracks.
So now, apply that identical mechanical logic to light.
Because light travels in waves too, right?
Yes, electromagnetic waves. If an object is emitting light, say a star or just a flashlight, and it is moving toward you at a very high velocity, those light waves get squished together in the exact same way.
The accordion.
The accordion. And in the electromagnetic spectrum, a shorter compressed wavelength visually shifts toward the blue end of the color spectrum.
Oh, so that is literally why it's called blue shift.
That's exactly why. And conversely, if the object is moving away from you, the light waves stretch out, like the slings.
And they shift to red.
You got it. That's redshift.
I'm with you so far. It makes perfect sense. If I'm flying a spaceship at, I don't know, Mach 20 through the universe, the starlight hitting the front window of my ship gets squished, and it looks visibly bluer to my eyes.
Yes, in classical terms, that's correct.
But here is the twist that really threw me when I was reviewing our sources for this deep dive.
A relativity twist.
Yeah. According to general relativity, you don't actually have to be moving for blue shift to happen, do you?
No, you do not. And this is where we transition from classical, everyday Newtonian physics into the deeply, deeply weird reality of space-time.
Okay, get weird. I'm ready.
Let's say you are sitting perfectly still in a chair.
Just lounging.
Just lounging. You have zero physical velocity. You are not moving through space at all.
Right.
But if the actual geometry of the space in front of you, the literal fabric of the universe itself, begins to compress.
Wait, the empty space compresses.
Yes. Any light passing through that compressed space gets violently squished along with it.
Let me stop you there, because that is a massive conceptual leap. I'm sitting in my chair. But the empty space in front of me is acting like what? A trash compactor.
That is actually a very apt way to visualize it. We have to stop thinking of space as this empty, static stage where things just happen.
It's not just a big empty box.
No, space is a dynamic physical medium. It can bend, it can stretch, and it can compress. So the light passing through that compacting space gets blue shifted.
Even though I'm not moving.
Right. You aren't moving through space. Space is compressing through you.
Whoa.
The blue shift is caused by the geometry of space-time changing, not by your physical velocity.
I was trying to come up with an analogy for this to help visualize the difference. Tell me if this works.
Let's hear it.
Think about driving a normal car down the highway.
Okay.
If you're driving normally, bugs hit your windshield. And the faster you drive, the harder the bugs hit.
Normal physics, moving through space.
Exactly. But if you are using exotic propulsion, if you are bending space-time to travel, you aren't driving through the bugs.
No, you're not.
You are sitting completely still in your driveway, but you've turned on a giant vacuum cleaner that is sucking the road, the air, and the bugs violently toward your windshield.
That is brilliant, yes. And in this case, the bugs are light itself.
Photons. Ambient starlight.
Right. The more you bend space to pull your destination closer to you, the harder that ambient light hits your windshield.
You're sucking the destination towards your windshield.
Exactly. In a warp metric, you are engineering the geometry of the universe to do the moving for you.
But hold on a second. If space is crushing together violently right in front of my windshield, what does it actually feel like to be the driver? Because if the universe is a trash compactor right outside my window, am I getting crushed inside the ship?
This is the genius of the warp metric. The answer is absolutely not.
Wait, really?
Nothing. You feel nothing at all. You are insulated inside what physicists call a localized flat metric.
Okay, localized flat metric for the listener who, isn't a theoretical physicist. Break that down for us.
It just means you create a bubble of perfectly normal, uncompressed, unstretched space around your ship.
Like a safe zone.
Exactly, a safe zone. The severe compression of space-time is happening entirely outside the front of that bubble.
Okay.
And the severe expansion of space-time is happening entirely outside the rear of that bubble.
But inside
the bubble, the space is flat, it is completely undisturbed. You would experience zero g-forces. Zero. You could have a cup of coffee sitting on your dashboard, and the surface of the liquid wouldn't even ripple.
That is just wild to think about.
Yeah.
The universe is literally folding in half right outside my window.
Yeah.
And I'm just sitting there sipping a latte in zero gravity.
Not spilling a drop, even as you traverse the galaxy at 1,000,000 times the speed of light.
But why does this specific distinction matter so much? Like, why is it so crucial that the space is bending rather than the ship just moving really fast?
It matters because of Albert Einstein's ultimate speed limit.
The speed of light.
Right. Velocity through space is strictly, unforgivingly limited by the speed of light. You cannot accelerate a physical mass through normal space faster than roughly 300,000 kilometers per second.
It's just a fundamental law of nature. You can't break it.
You can't. However, there is absolutely no mathematical limit on how fast the fabric of space itself can expand or contract.
Wait, really?
Really?
So the speed limit only applies to things inside the universe, not the universe itself.
Precisely. And we know this for a fact because of the Big Bang.
Oh, right, the expansion.
Yes. During the inflationary period of the early universe, space-time itself expanded exponentially faster than the speed of light.
Okay, that makes sense.
So by separating the concept of moving through space from manipulating the fabric of space, physicists realized that faster-than-light travel was technically permitted by the laws of physics.
Because you aren't breaking the speed limit.
No, you are just moving the road.
You're moving the road. I love that. And that realization brings us to 1994.
A very big year.
A huge year. This is the pivotal moment when the idea of a warp drive leaped out of, science fiction novels
Yeah.
and landed squarely on the pages of peer-reviewed physics journals.
Yes. Let's talk about Miguel Alcubierre.
Yeah, please. Who is he?
Miguel Alcubierre is a Mexican theoretical physicist, and the story goes that he was actually watching an episode of Star Trek.
No way.
Yes. He was looking at how they portrayed the warp drive on the show, and he started wondering if that concept could actually be reconciled with Einstein's general relativity.
I love that so much. A brilliant physicist is just watching TV and says, I could probably write the map for that.
And he did. He looked at Einstein's field equations.
Which are what, exactly?
These are the exact same highly complex tensor calculus equations that describe how black holes work.
Okay, heavy stuff.
Or how galaxies cluster together. Very heavy stuff. And Alcubierre asked, can I manipulate the geometry of space-time in these equations to move a bubble of flat space from point A to point B faster than light?
And I really want to emphasize to you listening right now, this isn't a sci-fi writer's thought experiment.
Not at all.
This is rigorous, peer-reviewed tensor calculus. And the math said yes.
It did.
Yeah.
Alcubierre mathematically proved that you could theoretically compress space ahead of a ship and expand space behind it.
It was a monumental breakthrough.
It was. It proved that a warp drive is a legitimate mathematical solution to general relativity, but almost immediately after Alcubierre published his paper, the wider physics community started poking at the math.
As they do.
As they do. They wanted to see what would actually happen if you tried to build this in the real physical universe. And they found a catastrophic flaw.
The ultimate showstopper. The blue sheet.
Yes, the blue sheet. So go back to your windshield analogy.
The vacuum cleaner sucking up bugs.
Right. As this warp bubble moves through the universe, it sweeps up every single stray photon in its path.
And space is full of stray photons, right? It's not totally empty like people think.
Far from it. You have ambient starlight from billions of galaxies.
Right.
You have the cosmic microwave background radiation.
Which is like the echo of the Big Bang.
Exactly. The lingering electromagnetic echo of the Big Bang itself that permeates every single inch of the universe.
So my windshield is just constantly accumulating cosmic bugs.
Right. But because of the extreme, violent spatial compression happening at the front wall of your warp bubble, those photons don't just hit the windshield and bounce off.
What do?
They get infinitely blue shifted. Infinitely. As the space compresses tighter and tighter, the wavelength of that ambient light gets squeezed. And when you squeeze a wavelength, its energy level spikes astronomically.
Okay, so the energy goes up.
Way up. As your warp bubble accelerates toward and then past the speed of light, the mathematical equations show the energy piling up on that front wall, climbing toward infinity.
A layer of infinite energy covering the front of the ship.
Yes. Physicists began calling it the gamma-ray death wall, or the blue sheet.
Gamma-ray death wall. That sounds like a heavy metal band.
It does, but it's a very real mathematical problem. It is a wall of ionizing radiation with practically limitless energy. And the implications of this are genuinely horrifying.
Because what happens when you stop?
Exactly. The moment you arrive at your destination and turn off the warp drive.
Just dropping out of warp to, explore a new planet.
Right. That entire accumulated wall of infinite energy doesn't just vanish. It detaches from the collapsing bubble and continues moving forward.
Oh my God. It's like slamming on the brakes in a pickup truck that's carrying a massive load of loose steel pipes in the back.
That's exactly it.
The truck stops, but the momentum carries the pipes right through the back of the cab.
That visual is entirely accurate. Except, in this case, the pipes are a sterilizing beam of infinite gamma radiation.
So you would instantly vaporize whatever solar system you just traveled across the galaxy to visit.
Yes. And frankly, the internal radiation dynamics of the bubble would likely have already incinerated you inside the ship before you even arrived.
So it's like, we come in peace. Oh, wait, we just accidentally turned your sun into a supernova. Or bad.
A very bad day for everyone. And this blue sheet problem became the literal brick wall of exotic propulsion.
I can see why.
For 30 years, it has been the primary reason orthodox physicists roll their eyes and say warp drives are physically impossible.
But let me play devil's advocate here for a second, because something about this doesn't add up to me.
Okay, shoot.
You just said Alcubierre's math was a legitimate, peer-reviewed solution to Einstein's equations.
It is.
And Einstein's equations are some of the most tested, proven math in human history.
Absolutely.
So if the math is right, How can the logical result of that math be an infinite death wall? I mean, nature doesn't really do infinity, does it?
No, it usually doesn't.
So when physics equations start spitting out infinities, doesn't that usually mean we've done something fundamentally wrong? Like, is the math broken?
That is perhaps the most important question in modern theoretical physics, and the answer is no, the math isn't broken.
It's not.
But the rule book we are using to read that math is missing a few pages.
Okay, I need you to explain this rule book. Why can't Einstein's framework fix the blue shift?
To understand the limitation, we have to talk about something called a symmetry group.
Let's pause right there. For the listener who, hasn't taken advanced graduate level mathematics, what is a symmetry group?
In physics, a symmetry group is essentially the mathematical toolkit that defines what operations are allowed in your theory.
It defines the rules of the game.
Exactly. If you are building a physical theory of the universe, the symmetry group tells you exactly what kinds of movements and transformations you are mathematically allowed to describe.
Okay.
Now, Einstein built general relativity using a very specific symmetry group. You can think of it as a physical toolbox that contains exactly 6 tools.
Just 6 tools. What do they do?
Well, 3 of those tools are for rotations.
Okay, like spinning on an axis.
Right. They describe how you can spin an object around the X, Y, and Z axes in 3-dimensional space.
Got it. And the other 3?
The other 3 tools are called boosts. They describe how you can change your velocity, how you speed up or slow down along those same 3 axes.
So 3 rotations, 3 boosts, a total of 6 tools.
Yes.
So you're telling me that Einstein's entire theory of gravity,
Yeah.
the math that explains black holes, galaxies colliding, the expansion of the universe, the GPS satellites in our phones, all of it is built using just a 6 toolkit.
Yes. And it is a phenomenal toolkit. I mean, for almost everything we observe in the cosmos, those 6 tools work flawlessly. But when you take this specific 6 toolkit and attempt to apply it to the extreme, highly anomalous environment of an Alcubierre warp bubble, you run into a glaring deficiency.
Something's missing.
There is a fundamental tool missing from Einstein's box.
What's the missing tool?
There is no mathematical tool for scaling, or what physicists call dilation.
Scaling. You mean like zooming in on a photograph on your smartphone?
Yes.
Making the image larger or smaller without actually changing the shape of the objects in the photo.
Precisely that. Einstein's symmetry group has no mathematical operation that allows the underlying geometry of space-time to smoothly dilate or rescale its energy degrees of freedom at a localized point.
Okay, I think I see where this is going. It's like trying to fix a highly complex plumbing leak under your kitchen sink.
Right. Okay, let's hear the plumbing analogy.
You open your toolbox, and all you have is a hammer and a screwdriver.
Right.
Now, a hammer and a screwdriver are fantastic tools. They literally built the modern world.
They did.
But if you have a bursting pipe, a hammer is the completely wrong tool for the job. You can't hammer a pipe closed.
No, you'll just make a bigger mess.
Right. You need a wrench. You need a tool that can grip and turn a valve.
That is exactly what is happening with the blue sheet.
Wow.
Because Einstein's framework lacks a scaling tool, when the photon energy starts rapidly piling up on the front wall of the warp bubble, the math has no way to deal with it.
It has no wrench.
It has no pressure relief valve. The equations have absolutely no choice but to let the energy accumulate and compound infinitely, resulting in the gamma ray death wall.
So the math spits out an infinity because it literally lacks the vocabulary to describe what should actually happen to that energy in the real physical world.
Yes. The infinity is an artifact of a limited vocabulary.
That is mind-blowing. So the obvious question is, where do we buy a bigger toolkit?
Now we're getting to the solution.
If Einstein's box only has 6 tools, who has the toolbox with the wrench?
This brings us to the monumental fix, which relies on the work of mathematical physicist Sir Roger Penrose. Okay, Penrose.
Yes. Instead of using Einstein's limited 6 toolkit, modern exotic propulsion theorists, most notably Jack Sarfatti, realized you have to upgrade.
Upgrade to what?
You have to upgrade to Roger Penrose's Twistor Conformal Group. Sometimes you will hear it referred to as Penrose's conformal framework or just the full conformal symmetry group.
And how many tools are in Penrose's box?
15.
15.
Penrose's conformal framework has 15 generators compared to Einstein's 6.
Wait, slow down. You just use the word generator. What does that mean in this context? Are we talking about a power generator?
No, no. In mathematics, a generator is just the formal term for the tool itself. It is a fundamental operation that generates a transformation.
Oh, okay. So Einstein has 6 generators. Penrose has 15.
Exactly.
That is a massive upgrade. What do the extra 9 tools actually do?
Well, first, it's important to note that Penrose's framework describes the exact same underlying physics as Einstein.
So it doesn't throw Einstein out the window. Not at all. It doesn't contradict general relativity, but it provides a much wider, more complete description of nature.
Right.
And crucially, among those extra 9 tools in Penrose's framework is the exact tool Einstein was missing.
The wrench.
The dilation generator. Scaling. It also includes tools called special conformal transformations, which handle complex inversions and rescalings of space.
So we finally got our wrench. We have the pressure relief valve.
We do.
So how does this actually fix the blue sheet?
When you apply Penrose's larger conformal framework to the warp drive equations, everything changes.
Okay.
As the warp bubble accelerates and the ambient photons begin to pile up on the front wall, the energy spikes, just like before.
Right, the bugs are hitting the windshield.
But this time, the math doesn't break down into an infinite death wall.
Because we have the right tools.
Exactly. Instead, the dilation generator, the scaling tool, kicks in. It mathematically absorbs the excess energy.
Hold on, I need to stop you here because I'm getting a little confused. Now, I want to make sure we clear this up for the listener.
Sure.
Does the energy get safely vented into space like steam from an engine, or does it do something else? Because you said earlier that nature doesn't really do infinities. So is this energy real and just being managed, or is it not real at all?
This is a brilliant distinction to make, and it cuts to the absolute heart of the physics here.
Okay.
The energy looks infinite and lethal when you are doing the math with only 6 tools.
Right.
But when you use the 15-tool math, you realize the infinity was never physically real in the first place.
Wait, what?
The venting is a mathematical venting, not a physical one.
Oh.
The universe already knew how to handle the energy through scaling. Our human math just didn't have the words for it. The lethal wall of radiation was what physicists call a gauge artifact.
A gauge artifact. Okay, break that down for the listener. What is a gauge artifact?
A gauge artifact is basically a mathematical illusion.
An illusion.
Yeah. It is a glitch, a phantom problem, caused entirely by the fact that the observer is using an incomplete mathematical toolkit to measure a system. It looks like a physical barrier on paper, but if you were actually there in a spaceship, the barrier wouldn't exist.
So, wait. 30 years of the world's smartest physicists throwing up their hands, declaring that warp drive is impossible because of a death wall. And the wall was just a typo in the universe's rulebook.
Well, not a typo, just a misinterpretation born of a restricted perspective.
Wow.
When you view the problem from the wider perspective of the full conformal symmetry group, the wall simply vanishes. It was never actually there.
Okay, my mind is slightly melting right now, but I want to make sure you, the listener, fully grasp what a gauge artifact actually feels like.
It's important to ground it.
Yeah, because it sounds like extremely dense academic jargon, but it is actually a physical sensation that you have experienced.
I think we're going to the playground.
Yes, we are.
Yeah.
Let's ground this in a memory we all share from childhood.
Okay, set the scene.
Imagine you are 8 years old and you are standing on a spinning merry-go-round at the local park.
A classic.
And your older sibling is spinning it really, really fast.
Too fast, usually.
Always too fast. You feel a very real, very physical force pulling your body outward, away from the center, right?
Absolutely.
You have to grip those metal bars with white knuckles so you don't go flying off into the wood chips.
We all know that feeling.
We call it centrifugal force.
Right. And to the 8-year-old child standing on the merry-go-round, that outward force feels as undeniable and as real as gravity itself.
It feels completely physical.
But now, imagine you step off the merry-go-round.
Okay, I step off.
Go stand on the grass nearby and watch your sibling spinning.
Safely on the grass.
Look closely at the physics of what is actually happening to their body. Does that outward pulling force actually exist?
No, it does not.
Exactly. From the perspective of the grass, what we call the non-rotating reference frame, the only real physical force at play is the metal bar pulling your sibling inward in a circle.
Oh, wow.
Your sibling's body wants to travel in a straight line because of inertia. The bar keeps pulling them into a continuous curve.
So the outward centrifugal force was a total fiction.
A total fiction. It was a coordinate artifact, a phantom force, created entirely because you were trapped inside a rotating reference frame.
Centrifugal force isn't a real force.
Yeah.
It's just your body's inertia fighting the inward pull of the merry-go-round.
Exactly. And if we connect this to the bigger picture of exotic propulsion,
Yeah.
the blue sheet death wall is exactly the same thing, just one level up in complexity.
The blue sheet is the centrifugal force of a warp drive.
That is perfectly stated. When you are trapped inside the limited six-tool perspective of Einstein's mathematical framework.
The mathematical merry-go-round.
Yes, the mathematical merry-go-round. When you're on it, the blue sheet feels absolutely real. It looks like an insurmountable physical barrier of infinite energy.
But then you step off?
But when you step off that mathematical merry-go-round and you view the equations from the larger, complete perspective of Penrose's conformal framework,
The 15 tools.
the infinite wall vanishes. It's a gauge artifact. It is an illusion of the math. It's not physical. It is not a problem.
That is an absolute aha moment.
It changes everything.
We've solved the math glitch. We've proved the barrier is an illusion. But as we both know, math is just marks on a chalkboard.
Very true.
You can write equations with 15 tools all day long.
Yeah.
But how would we actually know if someone or something was actually flying one of these warp drives in our sky?
That is the essential pivot we have to make now, from theoretical physics to observational empirical science.
Because we need proof.
Exactly. And this brings us to the recent work of theoretical physicist Jack Sarfatti.
Okay, Sarfatti.
In 2019 and 2020, Sarfatti published a series of predictions based on this exact conformal metric engineering model.
And what did he predict?
He realized that if a craft, an unidentified anomalous phenomenon, or UAP, is using this specific type of warp drive to manipulate the geometry of space-time, it wouldn't just be invisible, it would produce a highly specific, highly anomalous signature that we could detect.
A signature that we could literally see on military radar or like advanced optical sensors.
Yes. Sarfatti mathematically predicted that a UAP utilizing a warp drive would produce a reversed Doppler effect.
Okay, let's unpack this reverse Doppler idea.
Let's do it.
Normal Doppler effect, like we discussed with the ambulance.
Yeah.
If it approaches you, the fan waves compress. It sounds higher, or in light terms, it shifts blue.
Right.
If it moves away from you, the waves stretch out, it sounds lower, or it shifts red.
That's classical physics.
So a reverse Doppler effect would mean?
It means that if a UAP is moving away from you, receding into the distance, the ambient light, the radar waves, or the sound waves bouncing off it, it wouldn't shift red, as all of standard classical physics dictates.
Wait.
They would shift blue.
Stop. Stop right there. If an object is physically flying away from me, it should look red. The wave should be stretching. Why on earth would it look blue?
Because of the unique engineered geometry of the warp bubble we discussed earlier.
The expansion and contraction.
Yes. Remember, to move forward, the bubble violently contracts space in front of it, and it violently expands space behind it.
Okay, yeah.
When the craft is receding from you, flying away, it is pointing its rear end toward you.
Right.
The rear end of the bubble is rapidly expanding space-time.
Okay, I'm tracking.
When photons, like a radar pulse from an F-18, or just ambient light pass through that rapidly expanding space behind the craft, they are given a massive kick of extra energy by the metric itself.
Oh, kick of energy.
The expanding space is physically pushing them outward toward you. So even though the physical craft is moving away from you, the space-time geometry throws the waves at you with higher energy.
Resulting in a blue shift.
Resulting in a blue shift.
So the normal rules of motion are totally inverted by the warp bubble.
Completely inverted.
A normal jet fighter flying away from a radar station shows a red shift. A warp craft flying away shows a blue shift.
Yes, and this is a profoundly important point in the history of this science.
Why is that?
This specific prediction, the reverse Doppler signature as a diagnostic litmus test for exotic propulsion, belongs entirely to Jack Sarfatti.
I'm glad you brought that up, because I noticed in the source materials that there seemed to be quite a bit of contention about who deserves credit for what in this field.
There is.
Why does it matter so much that this is Sarfatti's prediction?
It matters because in the realm of frontier physics, rigorous math is the only thing that separates actual science from science fiction.
Right. Show your work.
Exactly. For years, another prominent researcher named Hal Puthoff had been heavily promoting a very different model for UAP propulsion.
What was his model?
It was called the polarizable vacuum model, or PV.
Okay.
Puthoff suggested that you could engineer space-time by harnessing the quantum vacuum, things like zero-point energy and the Casimir effect.
The Casimir effect. I've heard that term thrown around in sci-fi movies, but what does it actually mean in reality?
At a very basic level, if you take two uncharged metal plates and place them incredibly close together in a perfect vacuum,
Okay.
they will actually be pushed together by a mysterious force. That force is the Casimir effect.
Wait, what pushes them?
It happens because the vacuum of space isn't actually empty. It is boiling with microscopic quantum fluctuation.
Virtual particles popping in and out of existence.
Exactly. Puthoff was suggesting that you could somehow harvest or manipulate this tiny quantum vacuum energy to warp space for a macroscopic spaceship.
It sounds cool, honestly.
Yeah.
Harvesting the energy of the vacuum itself.
It does sound cool, and it definitely caught the public's imagination. But Sarfatti stepped in and impartially evaluated Puthoff's PV model through the unforgiving lens of Einstein's actual field equations.
And what did he find?
Sarfatti proved mathematically that Puthoff's model fails completely.
Ouch. Why does it fail?
Because Puthoff never properly checked his vacuum theory against something called Einstein's coupling constant.
Coupling constant. Okay, another term we need to define for the listener. What is a coupling constant?
A coupling constant is simply a number in physics that dictates how strongly two different fields interact with each other.
Like friction.
Kind of. In Einstein's equations, the coupling constant dictates how much mass or energy is required to bend the fabric of space-time.
Okay.
And that number is incredibly, unfathomably weak. It is roughly 10 to the negative 43rd power.
10 to the negative 43rd power. That is a decimal point followed by 42 zeros and a 1.
It is microscopically small.
That is a number so small my brain can't even picture it.
What it means is that space-time is incredibly stiff. It is a very rigid trampoline. It takes the staggering mass of an entire star just to bend it noticeably.
Wow.
Puthoff was suggesting that the tiny microscopic quantum fluctuations between two Casimir plates could generate enough energy to warp space for a ship.
But the trampoline is too stiff.
Exactly. Sarfatti did the rigorous math and showed that because Einstein's coupling constant is so rigid, Puthoff's vacuum energy falls short by 30 to 40 orders of magnitude.
Oh, wow. So it's not even close to working.
Not even in the same ballpark.
Puthoff's model is like trying to derail a speeding freight train by blowing on it with a drinking straw.
That is exactly what it is like. Sarfatti completely dismantled the vacuum engineering approach.
So what does Sarfatti's model use instead?
Sarfatti's model doesn't rely on the weak vacuum. It uses the full conformal symmetry group operating inside specially engineered metamaterials, which we will get to in a moment.
Okay, can't wait for that.
But the key takeaway here is that Sarfatti actually did the rigorous tensor calculus, and his math resulted in a specific, falsifiable prediction.
The reverse Doppler shift.
Yes.
And that is so huge because it gives our military, our radar operators, and our astronomers something highly specific and abnormal to look for.
They don't have to guess anymore.
Right. They can just say, hey, if you see an object flying away from you at Mach 20, but the radar return is blue shifted instead of red shifted, you are looking at a warp drive.
It transitions the entire conversation from untestable hypothetical speculation into hard observational science.
But you said it gives us something to look for.
Yes.
What if someone already saw it, decades before the math even predicted it?
Ah, yes. This is where the story takes a turn from complex mathematics into extraordinary historical evidence.
My favorite part.
We have to look at experimental field data, and we find a massive anomaly recorded in 1993.
I love this part of the deep dive. Let me set the scene for you listening.
Please do.
The date is April 28, 1993. We were on West Searsville Road in Orange County, New York.
Very specific.
Very. It is a quiet, dark, rural area. There are no major commercial or military airfields anywhere nearby.
Perfect conditions for an observation.
Exactly. A field researcher named Dr. Bruce Cornett is out with his recording equipment, and he manages to capture both acoustic and visual data of an unidentified anomalous phenomenon flying overhead.
And this wasn't just a dot of light in the sky.
No, it was a massive, silent, flying black triangle.
A black triangle, one of the most classic, frequently reported UAP shapes in history.
Right. So Cornett has his audio equipment running, and he captures the acoustic signature, the actual physical sound waves in the air emanating from this enormous craft as it flies directly over him, and then visually recedes into the distance.
It flies away.
Yes. And this analog data just sat there for 26 years, largely ignored as an unexplained anomaly.
Just gathering dust.
Until Sarfatti's math came along.
Yes, because when modern acoustic experts apply spectral analysis to Dr. Cornet's audio data from 1993, they find the smoking gun.
Wait, what exactly is spectral analysis?
It is a way of breaking down a sound recording to see the exact frequencies and pitches present over time, like looking at the DNA of a sound wave.
Okay.
And when they looked at the DNA of the triangle sound, the acoustic signature showed a distinct, unmistakable blue shift, even as the physical target was visually receding from the microphone.
Wait, let me make sure I understand the gravity of this. The triangle was physically flying away from Cornet.
Yes.
But the sound waves were bunching up, shifting to a higher frequency, exactly as if it were flying toward the microphone.
Yes. The visual data showed it receding. The acoustic data showed it approaching.
But earlier we talked about light and radar blue shifting from the warp bubble. This is sound.
Right.
Does a warp drive affect sound waves in the air the exact same way it affects light waves in a vacuum?
Absolutely.
Really?
Yes. Because the warp bubble is physically compressing and expanding the underlying space-time metric itself. It is warping the container that holds reality.
Oh.
Anything propagating through that warped container, whether it is an electromagnetic photon of light, a radar pulse, or a mechanical acoustic wave of air pressure, will be subjected to the exact same geometric shift.
So the violently expanding space behind the receding craft pushes the sound waves outward toward the microphone with higher energy,
Creating an acoustic blue shift.
This is the holy grail of theoretical physics, isn't it?
It is exactly what you hope for as a theorist.
This is exactly like when Einstein predicted that massive objects would bend light. And then Arthur Eddington went out during a solar eclipse years later and photographed a starlight bending around the sun exactly as the math predicted.
It is the exact same scientific validation process.
Wow.
You have a theoretical physicist, Jack Sarfatti, using pure mathematics to predict a completely counterintuitive phenomenon. Reverse Doppler shift from a receding object.
Yeah.
Then researchers look at raw independent field data collected 26 years before the prediction was even made.
And it matches.
And it perfectly matches the weird math. It is independent retroactive confirmation.
It's stunning. The 15-tool math predicted the ghost, and the 1993 CAPE recorded the ghost in real life.
Couldn't have said it better.
Okay, so let's summarize where we are. We have established that the math works. The blue sheet death wall is a gauge artifact that vanishes when you use Penrose's larger 15-tool conformal framework.
Correct.
We have established that Sarfatti's math predicts a reverse Doppler signature, and we have raw acoustic field data from 1993 that backs it up.
We have the solid theory, and we have the observational evidence.
But here's the ultimate question. The million-dollar, or I guess trillion-dollar engineering question.
How do we build it?
Exactly. How do we actually build this thing? How do we, physical human beings, get our hands on Penrose's extra scaling tools in a physical laboratory?
It's a fair question.
You can't just draw a 15-tool toolbox on a chalkboard, point to it, and expect a spaceship to levitate.
You are absolutely right to push back on that. Mathematics must have a material bridge to physical reality.
Right. Math without engineering is just philosophy.
Exactly. And this is the most groundbreaking, practical part of the entire deep dive.
Okay, lay it on me.
We physically access Penrose's conformal framework through a phenomenon called torsion in specifically engineered magnetic materials.
Okay, we need to do a deep dive into torsion. What is it, and how does it relate to gravity?
To understand torsion, we have to contrast it with what we already know, curvature. Einstein's standard theory of gravity is entirely based on curvature. Mass bends space. The sun is incredibly massive, so it bends the space around it, creating a deep gravity well that the Earth rolls around in.
The classic science museum analogy. You put a heavy bowling ball in the center of a trampoline, and it creates a dip. You roll a marble, and it orbits the bowling ball.
That's curvature.
That's curvature, got it.
Exactly. But as we discussed earlier when we dismantled Hal Puthoff's failed vacuum model, the massive engineering problem with curvature is that its coupling constant is incredibly weak.
The 10 to the negative 43rd power number.
Right. You literally need a Jupiter-sized mass to create a meaningful bend in the cosmic trampoline.
So it's practically impossible to engineer a warp drive using mass and curvature because the energy requirements are astronomical.
Exactly. No human civilization can build a battery the size of Jupiter.
Right. If the only way to bend space is with mass, we are stuck in the mud forever.
But here is the secret the universe has been hiding.
I love secrets.
Mass is not the only property of matter.
It's not.
No. Elementary particles, like electrons, don't just have mass. They also possess an intrinsic quantum property called spin.
Spin.
They have built-in angular momentum, and while mass bends space, creating curvature, spin twists space.
To twist space. I need you to visualize that for me. What does a twisting space look like?
Imagine taking a wet towel and twisting it tightly in your hands to wring out the water.
Okay, wringing it out.
You are creating a spiral torsion field in the fabric of the towel.
Right.
In the universe, spinning particles create microscopic spiral twists in the fabric of space-time. That twisting is called torsion.
Okay, so mass creates bending, which is curvature. Spin creates twisting, which is torsion.
You got it.
Why is twisting better than bending for building a warp drive? Like, why does torsion solve our Jupiter-sized energy problem?
Because of the coupling constant.
Oh.
Inside a specifically engineered magnetic crystal, what we call a metamaterial, you can achieve something incredible. Imagine a crystal where you have trillions upon trillions of electron spins, all precessing and coherently aligned together.
Wait, precessing. What does a precessing spin mean?
Think of a spinning toy top.
Okay.
When you spin it, it stays upright, but the top of it wobbles in a little circle as it spins.
Oh yeah, that's slow wobble.
That wobble is called precession. If you can engineer a magnetic crystal where trillions of electrons are not only spinning but wobbling in perfect unison, their combined torsion coupling to space-time becomes astronomically stronger than mass coupling.
How much stronger?
40 orders of magnitude stronger.
40 orders of magnitude.
Let that sink in.
Let me try an analogy here to see if I am grasping the sheer scale of this efficiency jump.
Go for it.
Imagine I'm trying to open a massive 10-ton bank vault door.
A heavy door.
Very heavy. If I try to open it by pushing directly on the heavy metal hinge, that is like using curvature,
Yes.
I would need the strength of 100 elephants, a Jupiter-sized push, just to move it a single millimeter.
Because you have zero leverage.
Right. It's incredibly inefficient because I have zero leverage at the hinge.
A very apt comparison for mass coupling.
But using torsion is like just walking over to the far side of the vault door and pulling the handle.
Yes.
It is the exact same heavy door. It is the exact same physical system. But because I'm accessing it through the handle, the torsion sector, the leverage is perfect.
It is perfect leverage.
It is 40 orders of magnitude easier to move.
Yeah.
I can pull the 10-ton door open with one hand.
That is precisely how the material bridge works. When you pump these specific magnetic crystals with electromagnetic energy, you align the spins, you induce coherent precession, and you engage the torsion sector. You are pulling the handle of space-time.
Wow.
By doing this, you are physically accessing those extra scaling and dilation tools in Penrose's conformal framework, and you are doing it without needing a Jupiter-sized mass.
This sounds almost too perfect. I have to ask, to make sure the listener knows we aren't just making up torsion as some magic sci-fi buzzword to fix a plot hole.
Right.
This is real, established physics, isn't it?
It is entirely established bedrock physics.
Okay, good.
The gauge theory underlying this torsion physics was published by the brilliant British physicist Tom Kibble in 1961.
You use the term gauge theory again. Before we move on, explain what a gauge theory is in simple terms.
Think of a gauge theory as a mathematical rulebook that ensures the laws of physics remain consistent no matter what perspective or measuring system you are using.
Like translation software.
Kind of. If you measure a room in feet and I measure it in meters, the room itself doesn't change size.
Right.
A gauge theory handles the mathematical translations that keep the physics invariant or unchanging across different coordinate systems. Kibble used this math to describe the fields of elementary particles.
Okay, so Kibble writes the gauge theory in 1961. Then what?
Then, the specific mathematical connection showing exactly how particle spin generates torsion in the fabric of spacetime was published by Dennis Sciama in 1962.
Sciama.
And just to establish his credibility, Sciama was famously Stephen Hawking's PhD advisor.
Oh, wow. Okay.
This is not speculative fringe math cooked up on a blog. This is foundational theoretical physics from the 1960s that is only now being directly connected to real, tangible, engineered metamaterials.
That entirely changes the game for anyone trying to build a warp drive.
It really does.
Which brings us to how this new understanding differs from every other warp drive claim out there. Because let's be honest, if you go on YouTube or read pop science blogs, you will see a new warp drive breakthrough paper published every 6 months.
You see them all the time.
How does Sarfatti's torsion-based conformal framework differ from the rest of the noise?
It differs fundamentally in its core assumptions about the universe. Almost every other researcher in this field treats Einstein's six-tool framework as unquestionable, infallible gospel.
They accept that they only have a hammer and a screwdriver.
Yes. And they spend their entire careers trying to find exotic, almost impossible workarounds within that limited framework.
It's like they were trying to build a complex machine that swings the hammer really, really fast to somehow turn the plumbing valve instead of just buying a wrench.
Exactly. They propose harvesting massive amounts of negative energy, which may not even exist in macroscopic quantities in our universe.
Right.
They rely on the quantum vacuum, or they propose incredibly complex geometric configurations of the Casimir effect. But because they're still pushing on the hinge of curvature, their equations still stubbornly demand Jupiter mass amounts of energy to create even a microscopic warp bubble.
So under their models, the warp drive remains an insurmountable engineering impossibility.
It's perpetually 500 years away.
So everyone else has been trying to build an impossibly massive engine to overcome the wrong physics.
And Sarfatti just unlocked the right physics.
He recognized that the framework itself was incomplete.
Exactly. By switching to the full conformal symmetry group and utilizing the torsion sector inside precessing magnetic metamaterials, the energy requirements completely collapse.
They dropped by 40 orders of magnitude.
You no longer need the energy of a gas giant planet. You need the energy output of a conventional human power source properly routed through a resonant magnetic crystal.
It takes the warp drive from maybe in 1,000 years if we can harness a star to, wait, we can do this in a lab right now.
Which brings us to the most important point of all. What comes next? Where does this leave us today?
Let's talk about the future.
It leaves us with an active, applied, and testable research program.
Testable.
I want to emphasize this heavily. We are not talking about science fiction centuries in the future. We are talking about hypotheses that are testable today.
Because the predictions made by the Penrose conformal framework and Sarfatti's torsion coupling are entirely falsifiable.
Yes, falsifiable.
Meaning we can design a physical experiment that will either prove it right or prove it wrong. It's not just untestable philosophy.
Exactly. We don't have to guess, and we don't have to wait.
We can look for the reverse Doppler shifts in our skies using existing military and astronomical sensor technology.
And we can actively build specific magnetic metamaterials and test their torsion coupling in tabletop laboratory experiments. We can measure the resonant frequencies of these crystals when we pump them with electromagnetic energy.
This transitions exotic propulsion from a theoretical daydream into a hard engineering discipline with a testable endpoint.
It makes it real science.
That is incredibly empowering. For you, the listener, tuning in right now, think about the intellectual journey we just took together today.
It's been a ride.
An hour ago, the warp drive was a Star Trek fantasy blocked by an infinite wall of deadly radiation.
The blue sheet.
Now, you are walking around with a cutting-edge understanding of frontier physics. You know exactly what the blue sheet is, the windshield effect of compressing space-time.
Right.
You know why it stumped scientists? For 30 years, they were stuck using Einstein's six-toolbox.
They needed the wrench.
You know how to fix it by upgrading to Roger Penrose's 15-tool Twistor Conformal Group? Adding that crucial scaling tool to mathematically absorb the energy?
The mathematical venting.
You know the playground analogy, that the death wall is just the centrifugal force of a mathematical merry-go-round.
A gauge artifact.
And you understand the material bridge. You understand that pulling the handle of torsion using electron spin is 40 orders of magnitude more efficient than pushing the hinge of mass curvature.
You literally know more about the fundamental mechanics of exotic propulsion than a lot of people working in traditional aerospace engineering today.
That is just awesome.
As a final thought for the listener to mull over, consider what this story tells us about the nature of scientific discovery itself.
Oh, I like this.
We so often assume that progress requires discovering a completely new particle or a totally unknown force of nature.
Right, like we need some magic new element.
But sometimes the greatest leaps forward don't come from finding a new piece of the puzzle. They come from realizing we've been staring at the existing pieces through the wrong lens.
Wow.
The math for the conformal group has been sitting in libraries since the 1960s. The acoustic data from Bruce Cornett has been on a tape since 1993.
It just took a shift in perspective to see how they connect.
What other impossible problems in our world are just waiting for us to pick up a bigger toolkit?
I love that. The answers are already here. We just need the right tools to read them. Everyone tried to fix blue shift by engineering around it. We asked, what if the divergence isn't physical? What if you're using the wrong symmetry group? Turns out, you are.